let's look at solving equations with radicals. So let's say we had the cube root of 2x minus 1 plus 5 equals 11. And we wanted to solve that. So the first step you want to do is isolate the radical. And you see this is kind of a similar process when we did absolute values. You want to get the big kind of operation thing alone first. So I want to get rid of this 5. So I'm going to subtract 5 from both sides. And I'm going to get the cube root of 2x minus 1 equals 6. And the second thing I want to do is raise both sides of the equation to the power needed to cancel the root. Okay, so in this case, I want to raise both sides to the third power, because that'll cancel out the third root. Powers and roots are opposite operations, just like adding is the opposite of subtracting. So I get 2x minus 1 equals 6 to the third, 216, and then 2.5. Step is repeat above as necessary. So there may be times when you have more than one radical in an equation and you would want to isolate one of them, raise both sides, get rid of that first radical, and then work on isolating the second one to get rid of it. And then once you've gotten rid of all the radicals, like I have here, step 3, solve as normal. Okay. So I'm going to solve this equation. So add 1, so 2x equals 217 divided by 2, x equals 108.5, right? Sounds like a radio station or something. And then step 4, check your solution. I want to make sure this actually works in this problem. So I substitute that in for my value of x, and I get, well, 2 times 108.5 is 217 minus 1. Yeah. 217 minus 1 plus 5 equals 11. So 217 minus 1 is 216. The third root of 216 should be 6. This is 11, right? Okay, so 6. So does 6 plus 5 equal 11? Yes, so this answer works. Now, when you check your answers, I actually didn't have to check this answers. You only have to check for even roots. The reason why is it has to do with the fact that, let's say you had 2 equals negative 2. And I said, is that a true statement? Clearly you'd say that's false. Okay? But if I were to square both sides, notice what happens to that negative. It becomes a positive. Now I have something that's true. So I start with something with false. Because I squared it, it became true. Now, if on the other hand I said I have 2 equals negative 2, and I said, is that true? And you say, no, that's false. And you cube both sides, well, that's going to give you positive 8 equals negative 8. Well, that's still false. So, there's no change by raising something to an odd power. You're not going to get something that's necessarily true. It was false to begin with. Now you might say, well, what does that have to do with this type of problem? Well, I might be staring at something like one of these, and because there's x's and stuff, I may not realize it. But what I see is with odd powers and odd roots, you're not going to have that sign change occurring that you have with even powers and even roots. So, check your answer, but really, it's really only necessary if you're working with even roots, square roots, fourth roots, things of that nature. Excuse me. Okay. So let's see a slightly more complicated problem. Let's say we had square root of x plus 1 equals, well, here, I mean, we're going to do that. Let's say square root of x plus 1 plus the square root of x minus 2 equals 1. Okay? So I'm going through those steps. First thing I want to do is isolate the radical. Well, I got two radicals, so which one am I going to isolate? So, yeah, I don't know. Maybe I'll subtract this square root of x plus 1 both sides. So I get the square root of x minus 2 all by itself, and I get 1 minus the square root of x plus 1. Which one you move over doesn't really matter, because you're going to have to get rid of both of them eventually. Now what I'm going to do is I'm going to square both sides. Now that's important that you're squaring sides and not pieces. Not squaring individual terms, you're squaring the whole group. So on the left-hand side, that just gets rid of the roots, and you get x minus 2. But on the right-hand side, we're going to have to multiply this out. So one way you could do this is you could say, well, I just write another 1 minus square root of x plus 1, and, FOIL that out. That's what it means to be squared. You got two of them times each other. And that's okay if you want to do it that way. You could use the fact that we know that if you have two terms and you're squaring that, there's a certain pattern that this always follows. And that is the first part is squared, the last part is squared, and in the middle it's this times 2. The first part times the second part times 2. So 2ab. So it's always going to follow that pattern. So if you know that pattern, what I can do is just say, okay, well, it's going to be this first part squared, so 1. It's going to be the second part is going to be squared, so negative square root squared. Negative squared is a positive. You square square root, that gives you what's inside, x plus 1. And then in the middle, it's going to be 1 times the negative square root times 2. So 1 times the negative 1 is negative 1, times 2 is negative 2, times the square root, x plus 1. That's how it's going to work out. Now, same thing if you work this out. If you were to say, okay, well, could I do it this way? Sure. You think about if you FOIL, you get 1. 1 times the negative root is a negative root. Negative root times 1 is a negative root. And negative root times negative root is a positive root squared. Right? And so what do you get? You get 1. You get 2 of these, so negative 2 root. And then you square the square root and you get x plus 1. So it's the same thing. If you feel more comfortable FOILing it out, go ahead. But really learning this pattern here is very valuable. For one thing, it's good going the other way when you're factoring this perfect square trinomial, but going this direction as well is very important. All right, so what I want to do now is repeat the process. I want to get the root by itself. So I'm looking to get this part by itself. Now, a real question might be, well, what about this negative 2 that's attached to it? Do I want to get rid of that? And the answer is, well, maybe. Maybe I want to get rid of it. I'm going to see what happens. We'll see how things play out. Maybe I might want to keep it. I don't know. Doing this kind of multiplication where you're adding and squaring is different and a little bit more complicated than if you're doing, say, a times b squared. That's pretty straightforward. That's a squared b squared. So if you have two things that are multiplying each other and you square it, well, you square both pieces individually, using this pattern here. Whereas if you're adding like we did, or subtracting like we did here, as you can see, it's a little bit more complicated. So let's work on solving this. So I want to get rid of this 1. I want to get rid of this 1. These parentheses aren't really doing anything. They're just decoration. And so that means I want to subtract 2 from both sides. 1 and 1. I want to get rid of this x. I'm going to subtract x from both sides. All right. So the x's cancel out. I get negative 4 equals negative 2 square root of x plus 1. Now I want to get rid of, do I want to keep this -2 or do I want to get rid of it? Well, if I look at the other side, if I were to divide both sides by -2, that's going to go in evenly. So yeah, this would be a good time to do that. Whereas if, let's say, this was a 5, then I wouldn't want to do that because I may not want to work with fractions. So you want to pick whatever method is going to, whatever choice is going to be the easiest on yourself. That's the choice you want to make. So I'm going to get rid of this square root. So I'm going to square everything again. X equals x plus 1. Subtract 1. 3 equals x. Maybe 3 equals x. I still got to check it. So I need to plug this back in to the original problem. So if I do that, change all of them to x's, or all the x's to 3's, that's going to give me 3 plus 1 is 4, plus 3 minus 2, 1. That should equal 1. So 2 plus 1, does that that equals 3, which is not 1. So nope, that didn't work. No solution. Which isn't surprising. I just made this problem off the top of my head, so it's not surprising it wouldn't work. I could have changed things around, to make it work, but maybe put a minus sign. If this had been a minus sign, then it would have worked out. But I didn't do that, so sometimes things you get answers and sometimes you don't. No solution.